Welcome to this explainer. Today, we're going to jump from the textbook right into professional practice. We're zeroing in on two absolute cornerstones of electrical engineering: how to get precise measurements, and, just as important, how to maintain uncompromising safety. Honestly, these are the skills that really separate an amateur from a pro.
So this is the big question, right? It really gets to the very heart of what we do. Our whole job is about working with this incredibly powerful, invisible force. You can't see it, you can't hear it, you can't smell it. So how in the world do you even begin to understand it, let alone control it?
Well, the answer, of course, is in our toolkit. We need instruments that can basically act as our senses. Things that can translate that invisible world of volts, amps, and ohms into a language we can actually see and understand.
And that brings us to what is, without a doubt, your single most important tool, the digital multimeter, or DMM. If you work with electronics, this thing becomes an extension of your own mind. It's how you literally peer inside a circuit to see exactly what's going on at any given moment.
Now, the DMM is the standard for a reason. It's super accurate, it's easy to read. But a real pro knows the limits of their tools. For instance, imagine you're trying to figure out why a power supply is acting up. A DMM's display might just be a blur of numbers, jumping all over the place. But an old-school analog meter, that needle will physically sweep back and forth, giving you this immediate, intuitive feel for how unstable the signal is. That's a huge advantage you just can't always get from a digital screen. All right, so we've got our tool. Let's actually put it to work. We're going to walk through one of the most basic things you'll ever do, measuring the resistance of a component. But what's cool is, as we go through this, the procedure itself is going to reveal a principle that's even more important than the measurement. Okay, look closely at these steps. The very first two things you do have nothing to do with measuring. They're about shutting things down. Why is that? Well, an ohmmeter works by sending its own tiny bit of current through the component. If the main circuit power is still on, not only are you going to get a totally wacky reading, you could fry your meter or even the circuit. So you see, this procedure shows you that proper measurement and safety are completely tangled up together. You can't have one without the other. And that leads us perfectly into our next topic. You know, learning how to measure a circuit, that's one thing, but learning how to respect the power inside it, that's what truly makes you a professional. This isn't about being afraid of electricity. It's about being in complete, total control of it. And that control starts with understanding the hazards. We see numbers like 120 volts all the time. It's on our appliances, our wall outlets. It's so common that it's easy to get complacent, to just stop seeing it. But in the lab, that number needs to be a wake-up call. It's a potential hazard that demands your full attention and professional respect, every single time. I really want you to burn this quote into your memory. This is not a friendly suggestion. This is a foundational law of our profession. Assuming a circuit is off is just a gamble. Verifying it with your meter, that is engineering. And that simple difference is what prevents accidents and, yes, saves lives. So let's build that professional shield right now. These protocols are your code of conduct. This is how you behave anytime, anywhere you're around electricity. These are the habits that are going to keep you and everyone around you safe. Think about what each of these points is actually doing. Electricity is always looking for the easiest way to get to the ground. And guess what? The human body is a pretty good conductor. So dry shoes, a rubber mat, dry hands, these are all insulators. They're all ways of making yourself a much, much less appealing path for that current to take. These aren't just rules for a class. They're the habits that literally keep you out of the circuit for your entire career. And if you want a perfect example of how seriously safety is taken out in the real world, look no further than this. Lockout/tagout is a formal, often legally required procedure. We're not just talking about flipping a switch off. We're talking about physically putting a padlock on the power source so that absolutely no one can turn it back on by accident while you're working. This is what top-tier safety looks like. Let that sink in for a minute. The laws of physics don't care if you're a first-year student or a 30-year veteran. The circuit doesn't know the difference. Your safety discipline has to be just as consistent and unforgiving, so make it your default habit starting today. Because in this field, your most valuable asset isn't your brain, and it's not your tools. It's your unwavering, non-negotiable commitment to safety.